the alkaloid poisons with Dragendorf reagents. The use of spectroscopy and other instrumental analysis techniques became common in forensic technology. In forensic toxicology, analysis was done strictly by wet chemistry techniques because many different plant alkaloids such as nicotine, strychnine, aconitin, and quinine are fatal in small doses. Forensic chemists during the 19th and early 20th centuries devoted considerable effort to develop reagents that could detect alkaloids at very low concentrations. Many of these reagents are general alkaloid reagents, providing positive results with many or most alkaloids. Others were used to differentiate specific alkaloids. Most of these alkaloid reagents were named for the chemists who invented them. A few of those reagents remain in use. However, and one of those is the wonderfully named Dragendorf's reagent, an acidic solution of bismuth and potassium iodide that yield a distinctive orange precipitate with most alkaloids. Dragendorf's reagent is still used for presumptive spot test for alkaloids, but its primary use in modern forensics lab is as a color developer for chromatograms that have been used to separate mixtures that contain alkaloids because Dragendorf reacts with most every alkaloid to yield the orange positive. Dragendorf is an excellent general alkaloid reagent. This reagent is sprayed on paper or TLC chromatogram where it develops any alkaloid spots present to a distinct orange hue. By calculating the RF value for each of those spots, a forensic scientist can unambiguously identify the specific alkaloids present on the chromatogram. Prepare the questionnaire alkaloid specimens. In this procedure, we prepare specimens of various substances that may contain alkaloids and test them using Dragendorf's reagent for the presence of alkaloids. Dragendorf reagent is non-selective in the sense that nearly any alkaloid yield a positive test, a bright orange suspension that settles as a bright red-orange precipitate. Dragendorf reagent is quite sensitive. It produces a positive test with some alkaloids at concentrations smaller than 1:, and many alkaloids concentration smaller than 1:10,000. The degree of preparation necessary varies according to the source of the alkaloid. Some specimens such as tonic water or cough syrup can be tested as without further preparation, if necessary, diluted with distilled water. To test for alkaloids present in pharmaceuticals, in which the alkaloid is normally present in water-soluble hydrochloride form, we can simply dissolve a small amount of the powder in few milliliters of water. For alkaloids in free base form, such as those present in plant material and in unprocessed foods, such as poppy seeds, crush a small amount of the plant material and choke it in dilute hydrochloric acid to convert the free base form of the alkaloid to soluble hydrochloride form. Label 15 ml centrifuge tube for each of your known and a question specimen. For tablet capsules and other pharmaceutical specimens, Crush the specimen to powder form and transfer it to the tube. Add about 3 ml of distilled or deionized water to the tube and swell it thoroughly to mix the content. Stand the tubes in the test tube rack or a beaker and allow the specimens to dissolve. Don't worry, not all of the powder goes into the solution. So record each tube content in the notebook. For seeds, leaves and other vegetable specimens, use the clean stirring rod or a spoon or crush each specimen thoroughly and transfer it to a tube. Add about 3 ml of distilled water or deionized water and about 0.25 ml lie nearest the tip of the pipette. 6.6 m hydrochloric acid to the tube and swell to mix the content. Stand the tube in a test tube rack or a beaker. Swell it thoroughly and then allow the dilute acid to extract any alkaloids present in the specimen. Test the specimens for the presence of alkaloids. Label the 6 tubes from A through F and place them in a test tube rack. Transfer about 2.5 ml of each alkaloid solution to the corresponding test tube. Transfer about 0.5 ml of Dragendorrf reagent to each tube and observe the result. If an alkaloid is present in relatively high concentration, the liquid immediately assumes a bright yellow-orange appearance or orange precipitate that settles down to the bottom of the tube, leaving the suspension liquid clear. If an alkaloid is present in low concentration, the liquid assumes a cloudy appearance and it may take the precipitate some time to settle. At very low concentration, it may take a few minutes for slight cloudiness to develop. Record your observations. Analyze the alkaloids using paper chromatography. Dragendorrf reagent is a good precipitation reagent for alkaloid testing. But precipitation tests tell us nothing about the identity of the alkaloid. In this procedure, we use paper chromatography to produce chromatograms of known alkaloids. Visualize this chromatogram with Dragendorrf reagent and determine the RF value for each alkaloid. Then produce a spot chromatography strip with a mixture of alkaloids. Develop and visualize the chromatogram and determine the RF values for each alkaloid present in the mixture. Cut the enough chromatography paper strip for each of your specimens and one spare. Each strip should be about 2.5 into 10 centimeter, just long and wide enough to fit inside a 50 ml centrifuge tube. Cut 2 corners from the same end of the each strip to allow the bottom of the strip to protrude into the conical part at the bottom of the tube. Draw a pencil line across the width of each strip, about 2 cm from the pointed end of the strip. Put a small dot near the center of each line. At the top end of each strip, label it for the corresponding alkaloid. We use the 50 ml of centrifuge tube as chromatography jars. Transfer enough hot water to each tube to fill it just to the top of the conical section at the bottom of the tube. Use a clean toothpick for each solution. Spot each of the chromatography strips with the corresponding alkaloid solution from each centrifuge tube. Transfer the tiniest possible drop from the tip of the toothpick to the center mark on the line of each strop. Allow each spot to dry as you spot the other strip. When you spotted all of the strips with your own alkaloid solutions, repeat the spotting for all the strips. Try to place each new spot directly on the top of the tried spot. The goal is to get the smallest and most centralized spot possible on each strip. Re-spot each strip until you have spotted it at least 5 times and then allow the strips to dry completely. Choose 2 or 3 of your own alkaloid solutions. Transfer 3 drops of each solution to the same well on the spot plate. Use the tip of a clean toothpick to mix the solutions. Spot the extra chromatography strip with a solution of mixed alkaloids. Allow it to dry and then re-spot it a total of at least 5 times. Holding the first strip outside one of the 50 ml centrifuge tubes. Verify that the water level in the tube is not high enough to reach the spot on the strip. As quickly as possible, remove the cap from the tube. Slide the strip into the tube. So repeat the step number of times. Keep a close eye on the tubes to watch the development progress. The paper strip draws up water from the bottom of the tube by capillary action as the development processes. The solvent front line climbs higher and higher on the strip. When the solvent front line approaches the top of the strip, uncap the tube and remove the strip. Place the strip aside to dry on a clean sheet of paper or a paper towel. Before it dries, use the pencil to make a horse mark on either side of the strip to indicate the maximum progress of the solvent front. If you have an ultraviolet light source available, you should always use it first to visualize the chromatogram, such as Dragendorf's reagent or iodine fuming. Many colorless analytes, including some alkaloids, fluoresce under UV light. Take your developed chromatograms into a closest or other darkened area and view them under your UV light source. If any analyte traces are visible under UV, use the pencil to mark their positions and extent. That shows the striking blue-green fluorescence of the alkaloid quinine, which is present at only 83 parts per million in a bottle of tonic water. Place the first chromatogram on a clean sheet or paper towel. Transfer a couple of drops Dragendorf's reagent to a cotton swab. Put the tip of the swab at the top of the center of the strip and wipe downward, damping the center of the strip along its length until you reach the spot if necessary. Add more reagent to the cotton swab. The goal is not to choke the entire strip, but to dampen the area of the strip where the alkaloid traces are present. Depending on the particular alkaloid and the amount of present in the trace, a yellow-orange batch may appear immediately, or it may take a few minutes to become visible. Using a fresh swab each time, repeat the step for each of the other chromatogram also. Thank you.